Alright, me matey, time to talk about scale and scale factor, working with different kinds of ratios to help us understand how to manipulate change, if you will. So, let's talk about scales before my pirate gets too hungry and my mateys need to go and, you know, plunder something or whatnot. I don't know. That's what pirates do. Okay, so we have a model airplane is built with a scale of 1 to 24. So I'm going to write that down. I got a 1 to 24 scale. It's a nice little scale we have here. Right? I can even turn this into a nice little box here, and I can say, okay, I got my scale. Let's move these words out of the way. Scale. And then I have the actual measurements that I'm going to use. And I'm going to have a model here. And then I'm going to have the object that I'm actually measuring it against. Okay. Now we have this beautiful picture we can use. Now we can continue. Okay, so here we have 18 inches happens to deal with my model. So I can put my 18 inches here. And it's 1 to 24. So because it is 1 to 24, I need to first convert everything. Well, I just need to solve for my object. All right. Now currently we're working with this label of inches, right? Putting right there, inches. Boom. So to solve this, I'm going to do some cross multiplication and division. So 18 times 24 divided by 1, 18 times 24 divided by 1 gives me a beautiful, beautiful answer of 432 inches. Now, of course, if I were to work with this, I would understand that measuring in inches on a very large airplane, probably not a good idea. So instead, I need to convert it to feet. Now, because of this, I know that the ratio of feet is 1 foot is 12 inches. So I can multiply like that. And so 1 times 132 is 432. But then we divide by 12 and we get a wonderful answer of 36 feet. So 18 inches is equal to 36 feet. So if you would say 1 inch is 24 feet, we got to take all of these different ideas to make sure we have everything we need to solve correctly. What a beautiful example of how this works. Let's try another one together. All right. Okay, so Sophia is modeling a model of a car from clay. Interesting. The scale of the model is 1 to 36. Oh, let's put together a nice scale box, eh? R, that's what I mean, not A. R. We need to work on me pirate a little bit more. All right. Anyway, then we have our measurement. And of course we have our M for model and O for object, and our scale is 1 to 36. So that's just a scale. No labels really included in this situation. But what we do know is we have this very difficult thing that we need to deal with. We have 4 feet and 6 inches. 2 different measures. A mixed measure, if you will. But if we take it and we convert it to one measure, it can save us some time. So let's do that. We want to get to inches, so let's take these 4 feet and change them into inches. Now I know that 4 feet is the same as 12 inches divided by 1 foot, right? Unit measure, 1 foot gets rid of that foot, and 4 times 12 gives me 48. Beautiful. There it is. And so we got to add that to our 6 inches for a total of 54 inches. And now I have my measurements and I can solve to find this. And to do this, of course, it would be very, very difficult to just try and figure out a relationship here. Very hard to see. So instead, I'm going to cross multiply and divide. 54 times 1 is 54. And now I'm going to divide by my 36. And boy, wouldn't that have been nice if they gave us a slightly easier number, but don't worry, I'm a math pirate. I can do math. Okay, 1, carry the 2, 5, 9, subtract, and we get the, I'm putting on my pirate glasses now, just because, well, it makes me look debonair, if you will. Alright, we got an 8 there, we got the 1 there, we carry the 0 down. Okay, alright, let's put a decimal point down. 5 times 6 is 180. Alright, that's gonna cancel out. Boom! I have solved this mystery as a French pirate. Arr! Yeah, my pirate accent is not very good. Get rid of that question mark. We're doing 1.5 inches. We have solved this case, but we are pirates, not Frenchmen, and so confused. You are so confused about what my accent is. But what you are not confused about is the math. Perfect. My job here is done. But it's not. We got a little bit more to talk about. Now we need to figure out the opposite. How do we move from the scale where it was 1 to 24 or 1 to 36? Now we need to find what 1 is equal to. So how do we do this? What is the scale factor between these two similar triangles? Alright, I will figure out the scale factor. To find scale factor, we're going to use our principles of our similar triangles to help us solve this. See, easiest way to do this is to look at our shape and find corresponding parts. We can easily find relationships between. For instance, I'm going to take my 20 and my 25 because this side corresponds with this side. And so what I've seen here is this. We already know that to find the scale, we take, the scale factor, it's going to be a change. So if I take this dimension, my 20, and I multiply by my factor, I'm going to write an F for factor, I should get a bigger triangle. I should get an answer of 25. All right, that's what makes them similar, it makes it bigger. That's how the scale has improved. From here then, I can solve now this problem, right? And why did I choose 20? No reason. I just like those numbers, really. I could have done 12 and 15. I could have done 16 and 20. It's about the same. No difference, right? As long as you are choosing corresponding parts. Don't correspond? Great. Good. Right? That's how scale factor works. It's how much has it increased or possibly decreased if you're looking at it in that way too. But what we can do here then is we can solve this. 20 times the factor is going to give me 25. So if I want factor, if I want to find this factor, I'm going to divide by 20 on this side and divide by 20 on this side. So factor equals 25 divided by 20. Now that, of course, is not a very good factor. It looks too big. It's too hard. Our simple pirate minds can't handle this. Let's reduce it. French pirates. French pirates. I don't even know if that was a thing. Maybe. Doesn't matter. French pirates. Okay. 25, 20. We can factor out. Let's say a 5. So we get 5 and a 4. Now I'm like a British pirate. Let's just stick with what we got. All right, 54. Maybe I'm a Russian pirate. Who knows? Who knows? Yeah, 5 fourths. 5 fourths. And usually we don't want to leave this in fraction form. It's okay sometimes leave it in fraction form, but very often scale factors are in more of a decimal form. And so 5 fourths, 5 divided by 4, of course, equals 1/25. And so we could write or, but usually we see scale factor as a decimal. But not always, but usually, but not always. So what are we really looking at here? As we look over this concept for today, we've seen a couple different things. Scale factor is the relationship between two similar shapes. So how one shape has gotten larger. How? By what factor? By what amount? right? And so we call that the scale factor, right? The other thing we can find is what is called just scale. And scale, of course, tells us that relationship that exists. One of these equals so many of these. And we can use this as a ratio and proportions to solve all of these ideas. So here you go. This is your turn. Your turn to show me that you can be a pirate or a French spy or a Russian diplomat or whatever it is you want to be. You can be anything if you put your mind to it, I guess. You could be like a... Never mind. I'm done. Don't worry about that. But math. Math. Find your buried treasure. R. Solve this problem. A. Okay, so we have some dimensions, we got prisms, and we got 3 beautiful questions. If you can solve these questions, you will make it to the X. And of course, X marks the spot for the treasure of a pirate. F for me, I must go plunder something, I don't know, some gold, maybe a cookie jar, something delicious. That's it for lesson 98.